All right, so we're going to do lesson 10.1, which is adding and subtracting polynomials. The first thing that we're going to talk about is coefficients, okay? Now, coefficients are the numbers that are in front of the variable, okay? If you remember, the term variable, okay, means it's a letter. So like X, Y, A, B, whatever it may be, okay? Whatever that letter is, it's going to be the number in front of the variable, okay? So if I look at this first example here, I have negative 4x squared plus x to the third power plus 3. What I want you to do is I want you to list the coefficients, okay? Now I'm going to go back to this example, or the term, okay, and it says the number in front of the variable, okay? So I'm going to look right here. I'm going to look for my variables. I've got an x squared and an x to the third power. So I'm going to look for the numbers that are in front of those. The number in front of x squared is what? Negative 4. What's the number in front of x to the third power? 1. When I don't see it, I know that it's 1. Okay, now what about this number right here? It's a 3 and it's by itself. Is it in front of a variable? No. Then all it is just a standard number. It is not a coefficient. So that does not count for anything when I'm asking for coefficients. So my coefficients are negative 4 and positive 1. That's all I'm asking for there is what are the coefficients. So let's look at the next one. Let's look for my variables. I've got an x and an x to the third power. What is the number in front of x? Negative 1. What's the number in front of x to the third power? 2. Does 4 count as a coefficient? No. It's just a standard term, and I don't have to worry about it. So this is negative 1 and positive 2 are my coefficients, okay? The most important thing is that you remember coefficients are in front of the variable, okay? Now, we've got lots of different terms here that I want you to memorize. The most important one to memorize is this very first term, standard form. Every single answer that you write in lesson 10.1, 10.2, 10.3, 10.4, we keep going, okay, has to be in standard form. And what standard form is, it's the term with the largest exponent has to be written first. So the term with the largest exponent has to be written first. So let's say that I had a couple different terms, okay? Let's say I had 2x squared plus 3x to the fourth power plus 1x to the fifth power. Now, standard form means the term with the largest exponent, not coefficient. The coefficient has nothing to do with standard form, okay? The term with the largest exponent. So I'm going to look for my exponents. I've got a 2, I've got a 4, and I've got a 5. So standard form tells me the term with the largest exponent has to be written first. And then they're going to go in descending order from that. So let's say 5, then I'm going to look for a 4, then I'm going to look for a 3, then I'm going to look for a 2, okay? So which one of these terms has to be written first?
5.
Well, the exponent of 5, which the term is what? 1x to the fifth power. So I'm going to write 1x to the fifth power. I like to cross it out so that I know I've taken care of it. What has to come next?
3x to the fourth.
Plus 3x to the fourth. And what has to come last?
2x squared.
2x squared. Now you may say, but Miss Reber, we skipped x to the third power. Was there an x to the third power? No. So I just move right on to the next smallest variable. Okay? Like, let's say it went x to the fifth and x. Okay? That's x to the fifth and x to the first power. All right? Skip 4, 3, and 2. Okay? You've got to just write them in descending order. So largest to smallest. All right? Now the degree just is talking about your exponent. So when I say, okay, what is the degree of 1x to the fifth power? all that you're going to say is, oh, the degree is 5 because the exponent is to the 5th power. Okay? The degree of 3x to the 4th power is 4 because that's the exponent. Okay? The degree of the polynomial. Now let's take this one for example, like we've already done. 1x to the 5th power plus 3x to the 4th plus 2x to the 2nd power. Now, common sense would say, okay, if they're asking for the degree, which is exponent, of the polynomial, which means all the terms in this, I just add them up. 5 plus 4 is 9 plus 2 is 11, so my degree is 11. Right, that's what common sense would tell us. But that is not how it is done, okay? The degree of the polynomial, you just look for the largest exponent. What's the largest exponent in this polynomial? 5. So my degree of my polynomial is 5. Okay? You don't have to add them all up. All you're doing is looking for the largest one. And lastly, the leading coefficient. Now, I remember back from the last slide, the term coefficient means the number in front of the variable. Okay? So I'm looking for when the polynomial is written in standard form. That's key. It has to be written in standard form first. Standard form, like we said, term with the largest exponent is first. Then the leading coefficient would be the first number that is in front of a variable. Okay, so let's take the same one that we've been working with. 1x to the 5th plus 3x to the 4th plus 2x squared. My term is written in standard form because I've got 5, 4, and 2. Those are my exponents. The leading coefficient would be the very first number that is in front of a variable. So my leading coefficient here is 1. Okay, that's all that it is. All right, next, identifying polynomials by the numbers of terms. Now, polynomials, okay? Terms are separated by a plus or a minus. Terms are separated by a plus or a minus. So I can look at my polynomial, and if I have 3x plus 2x plus 6, okay, I've got 3 different terms because I look at the pluses and the minuses, okay, and I've got 1, 2, 3. I count in between them. So terms can only be separated by a plus or a minus. It could be a minus, okay? So there's 4 different types of terms that I can have. I can have a monomial, okay? The term mono means 1. So a monomial is only going to have one term. So 6x squared. There's no pluses or minuses beside it. That's the only term. A binomial, okay? A binomial has 2 terms. Think of the word bicycle. A bicycle has 2 wheels. That's what the term bi means. It means 2. Okay, so I look right here. I have a plus sign. So I count my terms. 1, 2. So I have 2 terms. That's what a binomial is. A trinomial. Again, think of a tricycle. How many wheels does a tricycle have? 3. So the term tri means 3. Okay, so I look at my plus and my minus here and I go 1, 2, 3. I've got 3 terms. And lastly, anything over 3 terms. We don't sit there and we say, oh, a quadnomial, oh, a quintinomial, or a pentanomial, or a hexanomial, okay? We don't keep going up like that. We just classify everything above 3 as a polynomial. The term poly means many, so it has many terms. It doesn't matter if it has 4 terms or 100 terms. We call it a polynomial. Again, I look for my plus or minuses here, and I've got 1, 2, 3, 4 different terms, so I would call it a polynomial. Now, it can be plus and minuses mixed in together. On this example, for whatever reason, I only did plus signs. It can be all minus signs. It could be pluses and minuses. It's just each term is separated by either a plus or a minus. Okay? So now, let's get into doing some work with these polynomials. What they want us to do is they want us to find the sum or add these 2 polynomials together. The main thing that you have to remember here is like terms. You have already learned about like terms. This is nothing new to you. We know that like terms have the same variable, so the same letter, and that letter is raised to the same power. So like x and x would be like terms, okay, if they had numbers in front of them. X squared and x squared are like terms. However, x and x squared are not like terms. They are the same variable, but they are not raised to the same power. I've got x and then x squared. So they're not like terms there. Okay? So what they want us to do is they want us to add these polynomials together. Again, standard form is key. So what I'm going to do here is I'm going to look at my first term before I do any addition or any subtraction and say, is this in standard form? Let's look. I've got 3. What's the exponent of negative 2x? 1 and x squared. 3, 1, 2. Is that in standard form? No. It has to go 3, 2, 1. So I'm going to rewrite it. I know that 5x to the third still stays first. And again, I like to cross it out. What needs to come next? Plus x squared. What's that number in front of x squared? 1. Go ahead and write that. It's going to be very helpful. Anytime you see a variable without a number in front of it, write a 1 there. Okay? What needs to come next? Minus 2x. And then you can put to the first power or you don't have to. Either one works. And then lastly, plus 7. Now, on this next set of terms here, 3x squared plus 7 minus 4x. What I'm going to do to add it, I'm going to teach you the vertical format because I think that's the easiest one, okay, is you just line up like terms. So I need to line up 3x squared with its like term. Let's look at it. 5x to the third power, 1x squared minus 2x plus 7. What's its like term? 1x squared. So I'm going to write underneath it 3x squared. And what is 3x squared? Positive or negative? Positive. So I put a plus sign in front of it because I am going to add, so I want to make sure I put that there. What does 7 need to be lined up with? The 7, because it's just a plain number. It does not have any variables at all. And lastly, what does negative 4x need to be lined up with? Negative 2x. Now, look right here. I don't have anything underneath the 5x to the third power. So what I want to do is I like to put a placeholder there. That placeholder is I just put a 0 and I just write the like term. Okay? That just tells me that 5x to the third power doesn't go away. Okay? It doesn't get canceled out. I'm going to still add it, but the term underneath it is a 0. Okay? There's nothing there. So now I just add it. 5 plus 0 is 5. Now, when I'm adding like terms, do I make this x to the 6th power or do I keep it x to the 3rd? Keep it x to the 3rd. Okay, I want to keep it x to the 3rd power. All right, now 1 plus 3 is 4. Again, keep it x squared. Negative 2 plus negative 4 is negative 6. Keep it x. 7 plus 7 is 14. Now, I told you at the beginning, every single answer has to be in standard form. Guess what? When we wrote those terms in standard form at the beginning, that took care of that. This is my final answer. 5x to the third power plus 4x squared minus 6x plus 14. That's my final answer. Okay, let's do the next one. 8x squared minus 2x plus 4. All right, so I'm going to rewrite this. I know that it's in standard form, okay, but I am going to go ahead and rewrite it. 8x squared minus 2x plus 4, because I know it goes 2, 1, then a number without a variable. So what I need to do is I need to line up these terms underneath it. So 4x squared, where is that going to go? Under 8x squared. Where is negative 1 going to go? Under the 4. Where is negative 3x to the third power going to go? It does not have a like term right now. But if I were writing this in standard form, where would that negative 3x to the third power go? In front of 4x to the second power. So I'm going to write negative 3x to the third. Then since I know that 4 was positive, I'm going to put a plus sign in front of it. Now, let's look at all these empty spaces that I have here. I know I need some placeholders. First of all, 3x to the third power. I need a placeholder over that. Again, I put a plus sign in front of the 8 because I know the 8's positive. I need another placeholder here under the negative 2x. Now all of my terms are taken care of. I just add. 0 plus negative 3 is negative 3x to the third power. 8 plus 4 is 12x to the second power. Negative 2 plus 0 is negative 2x. And 4 minus 1 is 3. So this would be my final answer. And again, I know that it's in standard form because that's what I did at the very beginning. All right, now we're going to move on to subtracting polynomials. Subtracting polynomials, okay? This is a little bit different than adding polynomials. And the reason why is because I have this minus sign right here. When I subtract polynomials, this is what I really want everybody to listen to. When I subtract polynomials, what I do is every single term after the minus sign. That's the kicker there. After the minus sign. I do not touch or do anything to any of these terms before the minus sign. I only change the terms after the minus sign. Every term after the minus sign, whatever the sign is right now, I'm going to take the opposite. So if it's a negative, I make it a positive. If it's a positive, I make it a negative. Then I can just add my terms together. So let's look right here. What is 2x to the third power? Positive. So I'm going to make it negative 2x to the third power. What is 3x? So I'm going to make it negative 3x. What is negative 4? Negative. So I'm going to make it a positive 4. What that does then is that changes this to an addition problem. And I'm just right back to where I was in the last example. Just line up my terms, make sure that they're like terms, and add them together. Okay, I'm going to look at this first set of problems. Is it in standard form? 3, 2, 1, nothing. Is it in standard form? Yes. So I'm actually not even going to rewrite it. I'm going to leave it just where it is. And I'm just going to line up the terms underneath it. Where should negative 2x to the third power go?
Under the other negative 2x.
Under the negative 2x to the third power. Okay? Where should negative 3x go?
Under negative 4x.
And where should 4 go?
Under 8.
Do I need to add a placeholder?
Yes.
Yes, so I'm going to put plus 0x squared. Now, I just add. Negative 2 plus negative 2 is negative 4x to the third power. 5 plus 0 is 5x squared. Negative 4 plus negative 3 is negative 7x. And 4 plus 8 is 12. I already know it's in standard form, so that is my final answer. So remember, everything after the minus sign is what you change. So right here I have this minus sign. So I'm going to change every single term after that minus sign. So the first term is going to become what? Negative 2x to the third. What's the second term going to become?
Negative 4x squared.
Third term?
Positive 3x.
And last term?
Negative 1.
Negative 1. Very good. Now, actually, I'm going to go ahead and look at this. And is this very last term in standard form?
Yes.
Yes. So what I'm going to do is I'm just going to put these things underneath the like terms that I already have. It does not matter. You can put the second term on top and the first term on the bottom, or you can do the first term on top, the second set of terms on the bottom. It does not matter, okay? As long as they're lined up with their like terms, it does not matter which one's on top and which one's on bottom, okay? So negative 6x to the third power should go under what?
Negative 2x.
5x should go And I'm going to put plus 5x because I know it's a positive. And negative 3 should go under negative 1. Do I need to add a placeholder? Yes, 0x squared. Add the terms. Negative 2 plus negative 8 is negative 2 plus negative 6 is negative 8, x to the third power. Negative 4 plus 0 is negative 4, x squared. 3 plus 5 is 8x. And negative 1 plus negative 3 is negative 4. And I already know, again, that it's in standard form. So this is my final answer. And that's how you add and subtract polynomials.